plucked from the trash. Everyday objects are destroyed, then transformed by technology, reborn into modern marvels. Train tracks are back on the rails as a luxury car. Detergent jugs find a new home in a durable parking pad. Truck shocks sharpen into a rapier sword. These are the things that are made by destruction. Trains connect the country, carrying people and hauling goods. In North America, 300,000 kilometers of tough steel highways can handle millions of tons of freight and thousands of passengers a year. But after decades of riding the rails, the worn-out tracks eventually get to the end of the line. They need to be retired and relaid. Now, these torn-up tracks have a new destination, technologically transformed into a sleek new ride. Every year, M Metal collects and processes 7,000 tons of scrap metal in their 9,000 square meter plant, repurposing steel for everything from coffee machines to suspension bridges. These retired train rails will soon be back on track, on the move again as a luxury Lexus RX SUV. To make the transformation, the retired rails are reshaped and refined back into usable steel. The first step in destruction is cutting. A front loader clutches the rail and carries it to a cutter. A belt feeds the rail into the powerful blade and cuts the solid steel rail into 1 meter chunks. The rails travel by train to ArcelorMittal Dofasco in Hamilton, Ontario, for the next stop in their transformation. The pieces of rail arrive at the furnace. A bucket adds the scrap to a ladle of liquefied iron, and it melts at 2,000 degrees. The molten steel then passes through a cooling vent, lowering the temperature and siphons into a cast which molds the metal into slabs. The hot slabs ride along a set of rollers, which moves the steel back and forth, squeezing it until it's 25 to 50 millimeters thick. Then it moves to another mill, where it's squeezed to 2.5 millimeters. Finally, the steel is coated with zinc to make it corrosion resistant, and it's rolled into 25 metric ton coils. What were once worn-out railroad tracks are gleaming sheets of steel, headed to the next station in their transformation. In the 52-hectare Toyota factory in Cambridge, Ontario, it takes only 24 hours to assemble a single Lexus RX. First, the floor, sides, and back of the steel body are stamped and welded together. The car body is then primed and painted. Finally, the drive system and other components are added. The first step in the creation process is called stamping. An overhead crane carries the steel coil above the factory floor to the press shop. It's fed into the blanking machine, where it's uncoiled. Computer-controlled blades cut the steel into a variety of sizes. A die press forces the blank onto a form. Using 2,000 metric tons of pressure, the stamp presses the steel into the side panel of a Lexus RX. Then, an automated handling device lifts the newly made part off the press. These side panels ride along the assembly line. where a robotic arm grabs them and stacks them. One of 800 steel parts ready to be assembled. An army of robot welders begin fashioning steel parts into the hard-wearing exterior of a superior road machine. Cast-off railroad tracks have been sliced, melted, and molded into sheets, then punched into parts that will make up the body of a high-end car. The panels are ready to be welded to the rest of the steel structure. The steel underbody rides along the assembly line. Automated arms pick up the side panels and fit them to the underbody. Robotic spot welders hold the parts in place. Then, a crew of 348 synchronized robots permanently weld the pieces together. 99% of the weld shop is automated. A cradle hoists the 550-kilogram car shell and carries it further up the assembly line. A team member guides a hydraulic arm to set the trunk lid in place. A little further down the line, the hood is attached. These highly trained team members can perform and double-check their task in just 120 seconds. By the time the car shell leaves the weld shop, team members and machines have performed over 4,000 welds. The steel body is complete and ready for paint. First, the shell of the car is submerged in an electro undercoating. Tiny particles of primer in the bath are given a positive charge, while the shell of the car is given a negative charge. The electrically charged primer is attracted to the car body like a magnet, giving the intricate shapes of the vehicle a perfectly uniform coat. Robotic nozzles spray along the body, applying a smooth, even top coat. The paint jets are designed to be clog-free, ensuring an even spray across every contour of the car and a perfect paint job. The body is a gleaming shell, but there's still lots to do before it's finished. The next step is assembly. In the assembly hall, over 2,000 parts and sub-assemblies are precision fitted. Team members install the instrument panel into the car's cabin. In the powertrain area, team members install a pre-assembled 6-cylinder 3.5-liter engine. A team member fastens the wheels using a pneumatic wrench to lock them in place. The plant's assembly line is 1.5 kilometers long. Along the way, the vehicle is subjected to 4,877 quality control checks. A brand new car rolls out of the plant every 2 minutes and rolls onto a transport train to be shipped to 27 destinations throughout North America. Discarded railroad tracks are back on board, reshaped and reimagined into a stylish new car. But before they start carrying freight and passengers of their own, they'll be riding the very rails they're made of. How's that for a round trip? There's nothing like a fresh load of laundry. The average North American household does almost 400 loads every year, using enough detergent to fill 700,000 Olympic swimming pools. And while your clothes are getting clean, the cast-off containers are making a dirty mess. 7 billion detergent jugs are tossed every year, enough to wrap around the world 6 times. But now there's a groundbreaking technology that's turning detergent bottles into a cool new pad. EFS Plastics takes in 80 metric tons of plastic waste every day. repurposing empty detergent jugs into an eco-friendly surface you can drive on. Discarded detergent containers will transform into the base of a groundbreaking new parking system. At the plant, recyclers shred, wash, and melt the laundry containers so they can turn the high-density polyethylene jugs back into a useful raw material. The containers arrive at the plant compressed into bales. A forklift carries the bales to the first step in their destruction, shredding. An operator lifts the bales of multicolored plastic and drops them into the hopper. The hopper swallows the 400-kilogram bales, then feeds them into a heavy-duty shredder. Spinning shredder blades chew up a bale every 2 minutes, grinding the containers into 25-centimeter plastic shards. The plastic shred cascades along the water-fed trough and is washed. The clean plastic floats to the surface, and the debris sinks to the bottom to be filtered out. A conveyor belt ferries the plastic pieces to the final phase of destruction. The shred drops onto an auger, which forces the material into an extruder. The extruder heats to 200 degrees Celsius, melting the plastic. Colorant dyes it a uniform black. The rotating screw pushes the gummy material through a screen, shaping it into thin strands. A mechanized blade chops the plastic spaghetti into 3-millimeter pellets. Water cools the pellets down. They skip along a vibrating grate and drop into a dryer. A chute loads 700-kilogram shipping bins with the tiny polyethylene pellets. Former detergent containers are now ready to be reformed into a water-permeable parking grid. The plastic pellets are melted down and shaped into the base of a revolutionary new parking pad. Recyclers shred and wash old detergent containers, molding them into reusable plastic pellets. The pellets arrive at MB Plastics in Linwood, Ontario. MB turns post-consumer plastic into groundbreaking new parking surfaces. The first step in the creation process is to melt the pellets down. A worker feeds the pellets into an injection mold machine. He uses a vacuum to draw the pellets into the machine's hopper. An auger pulls the material into a heating barrel, which melts it at 90 degrees Celsius. The auger squeezes the molten plastic into the mold chamber and presses it against the grid-shaped plate and is cooled. The newly formed parking grid shoots out of the machine. A robotic arm airlifts it to a waiting table. It's all over in 83 seconds. 1,000 grids every 24 hours. The load of parking grids hits the road. At the installation site, workers hammer the grid pieces together on pre-leveled ground. The hollow square design and flexible fins are easy to assemble and almost impossible to break. A front-end loader pours gravel and rakes it evenly over the parking pad. Gravel is a cheaper and more environmentally friendly alternative to asphalt. And while the water drains through easily, the grid barrier provides a rock-solid surface for commercial trucks up to 40 metric tons. Thanks to innovative thinking, you can park on the sustainable space and the meter never runs out. Whether your vehicle's carrying heavyweight freight or precious cargo, you want a smooth ride. And the key to softening the blow is in the suspension. Eventually, the 1 billion cars and trucks in circulation get to the end of the road. But the suspension can be saved. and crafted into cutting-edge technology, circa medieval Europe. U-Pullet 86 auto and metal recyclers in Roxeter, Ontario, salvages thousands of cars and trucks every year, and 95% of every vehicle gets to ride again. The salvage op tears up and grinds down the scrapped vehicles so they can harvest the parts for used cars and new products. A 21st century truck suspension spring will be reformed into a 16th century sword. Junked cars litter the wrecking yard like an automotive graveyard, ready to be reborn. To make the replica sword, not any metal can make the cut. But hidden inside every truck's suspension system is the flexible, durable steel the blacksmith is looking for. The first step in the destruction is to pull the metal part from the wreckage. A wrecking yard crane clutches the truck in its powerful jaws and bites down hard. It tears the truck apart to expose the coiled steel suspension. Most suspension springs are made of a tough low alloy or medium carbon steel, which makes it both very strong yet flexible enough not to crack under pressure. The perfect combination for forging a 16th century sword. A salvager sifts through the metal carcass and locates the suspension system. He finds the 3/4-inch spring and cuts it loose with an angle grinder. The coil is ready to be forged into a prized replica sword. A blacksmith applies old-world craftsmanship to stretch, heat, and hone a 21st century suspension spring into a 16th century sword. Salvage operators have torn up a junkyard truck to recover the suspension spring. The high-grade steel spring travels 20 minutes down the road and 500 years into the past. Every year, the blacksmiths at FAC Ironworks create 20 medieval-style swords using truck suspension springs. The suspension coil needs to be stretched and straightened before the alchemy can begin. In the workshop, the blacksmith heats the coil in a coal-stoked forge. When the temperature hits a red-hot 790 degrees Celsius, it's pliable enough to be worked. Using bending forks, the smith gradually unwinds the hot spring coil by coil, pounding and pulling until it's a single 90-centimeter long piece. The suspension spring is now a steel rod, ready to be reimagined. The first step in creation is to flatten the steel shaft. The smith guides the steel along the anvil, using a 35-kilogram power hammer to pummel and sculpt the rod into a steel bar. The blacksmith cuts off the blade by hammering it on the sharp edge of an anvil chisel. The craftsman puts the blade back into the forge, reheating it to 790 degrees Celsius. He hammers the blade, tapering the steel on either side, giving the sword a piercing point and lethal strength. The shaft is ready for the next stage in its transformation. The blacksmith eases the blade along a ceramic belt grinder, spinning at 1,000 RPM, shaving off minute shards of metal. It takes a skilled hand and years of experience to achieve this kind of exacting symmetry. The blade needs to be rehardened so the sharpened sword will keep its edge. The smith heats the blade in a propane forge at precisely 500 degrees Celsius. He pulls the blade out of the oven and lowers it into a tank filled with quenching oil. Quenching locks the molecular structure of the steel, helping it retain a razor-sharp edge. After about 45 seconds, the blacksmith pulls the sword from its quenching bath and readies it for tempering. Quenching can make the steel too rigid, so the tempering process re-softens the blade to keep it flexible and durable. The smith sparks an oxyacetylene torch and runs the flame along the center of the blade, heating it to 400 degrees Celsius. He wipes the blade with a water-soaked rag to cool it down slowly, which rehardens the metal in controlled stages. The final stage in the process is finishing. The blacksmith buffs the sword to a fine luster to bring out its unique facets. The sword is ready to be crowned. The craftsman slips on the skull-shaped hilt, inspired by the sword's pirating past. A single screw locks the ornate handle in place. Then, long strokes with a whetstone hone the blade to a surgical edge. The replica sword is complete, sought after by collectors who'll pay thousands of dollars for a stab at owning a piece of the past. New ways of thinking and old-world craftsmanship have resurrected a useless old truck spring and turned it into a sharp new showpiece.